Okay, surface area of pyramids and cones. Now, while we don't actually need to be able to show that we understand how we get the surface area formula of a cone or a pyramid, it's really quite useful to understand, so I'll briefly go through it. If you look at the net of a cone, it's made up of the circular base, with the radius given there, and a sector that wraps around the base of our circle there and meets up at this apex point here. We have the perpendicular height of a cone, that's perpendicular 90 degrees to the base, but the length, the dimension that we really want is the slant height, which makes up the radius of the sector that wraps around the circular base. So it's actually two circles, just one is a sector, not a full circle. So the area of the circular base is nice and easy, that's pi r squared. And we do need to get the area of the slant, the curved surface. Now, if this was an entire circle, that would be really easy. We'd get the area of this circle pi s squared. My apologies, we'd want pi times the radius, and the radius here is s. So that bit's easy. But we only need this fraction of a circle. Fortunately, we know this distance all the way around the sector because it's the circumference of the smaller circle. So the fraction of a circle that we have here, that we need the area for, can be worked out by finding the circumference of the smaller circle, 2 pi r, divided by the circumference of the larger circle, 2 pi s, and since that's the fraction of this circle we have here, we multiply it to get the area of the sector. Fortunately, we can simplify this down somewhat. We can cancel out the 2's, the pi's, the s and one of the s's, because of course this is still multiplied, so we are cancelling common factors. And so this comes down to pi r s. So my formula for the surface area of a cone is pi r squared, which is the circular base, plus pi r s. I have a terrible habit of writing s as a power. This is wrong, don't do it. Pi times r times s, no powers here. Obviously, this was our circle, this was our curved surface, and so if you just wanted to find the curved surface of an open cone without the circular base, you'd just use this part. We can factorize this if we have a full closed cone, because of course we've got common factors of pi r here, so pi r outside of r plus s is just fine. Either of these formulae work. This one you'd have to choose the correct part if you just wanted the curved surface of your cone. Square-based pyramids, so it's a square at the bottom. Here is the base of the triangle. It's easier if we look at this as a net to see what we're doing. So 4 identical triangles and a square. Again, we have the perpendicular height of the shape, which is perpendicular to this base here. But what we want is the slant height, because that gives us the height of the triangle, which we need for the area of the triangle, and this is the base down here. So you can see that my surface area is the square area, side of the square squared, plus 4 lots of half times base times height, which would give me the area of a triangle times 4. Simplify that down, of course, for our formula, base squared plus 2bh. So that's our surface area formula for a pyramid. If, of course, it was an open pyramid and didn't have a base, you'd get rid of that base squared. Yes, you could factorize it, I wouldn't bother. So a quick example. Now, if they give you a diagram, you don't need to draw it. If they don't give you a diagram, you must draw it. So if I asked you please to find the surface area of a cone with radius 2 meters and slant height of 4.5 meters, if I hadn't given you a diagram, you'd draw one for me. It's a closed cone. You can choose either of the formulae for the surface area of a cone. Let's use this one. You write your formula, substitute in your values. You can simplify anything if you want here, so that's 2 pi times 6.5, or of course we could have skipped straight to using our calculator. 2 pi times 6.5, and that's 40.84 units of meters. Its surface area, we're in meters squared.